Good afternoon, everyone. Today we're going to factor quickly two quadratic polynomials, 1 and 2. We're going to use algebra tiles for the first one and just decomposition for the second one. So, for the first one, we want to draw these terms with the algebra tiles in a way that makes a nice, perfect rectangle. That way we can look at the two dimensions of our rectangle and use those as our two factors, okay, to write our polynomial in factored form. So, first things first, we have three big x squares. 3 is a prime number, so we can either draw them one beside the other, or 3 stacked on top of one another. Does not matter. I'm going to go ahead and use the green for the positive x squares, and just by chance, I'm going to draw them one beside the other, okay? So, our first step. Next, we know we want to have a little pocket of 4 negative units down in the bottom right corner, again, either stacked or laid flat. And we want to end up with one negative x tile. Now remember, negative x or minus x really means minus 1x, right? When there's no number explicitly written in front of the variable, that coefficient is assumed to be 1, right? Important to remember, not 0. So now we need to figure out how we're going to distribute some number of x's beside the x squares and underneath the x squares to make a little pocket of units in the bottom right corner. Well, you can think of how that might work out, and you'll likely come to the conclusion that if we draw four negative tiles of x, one beside the other, like so, and if we join that with 3 positive x tiles like so, then the dimensions work out because x matches up with the side lengths of the big X squared, right? Remember, the x squared square has dimensions x by x, right? So the dimensions have to line up. And likewise, the dimensions of x, the dimensions of an x rectangle is x as the height, and the length is clearly 1, right? Likewise down here, the height is 1, the length is x. And so that's what creates this little pocket for the units down below. And our units are going to be negative. We know that because a positive times a negative is, of course, a negative. And so we get our 4 negative units down here, right? And now we have a perfect rectangle, right? We see our algebra tiles laid out in a perfect tight rectangle. So we can look at what we have in terms of our dimensions. Along the bottom side, we have 3x, and then we have minus 4. So we have 3x minus 4 along one direction, and then we have to be mindful of the other direction. But what it's going to be in this case is, if we look over here, our dimension is x plus 1, and those turn out to be exactly what we need for the factors of our polynomial. And so we can factor this quadratic polynomial as its 2 dimensions, namely x plus 1 times 3x minus 4. And we're done, okay? Now, if you're ever unsure, as maybe sometimes you will be, you can always check your answer by expanding through the brackets and ensuring that it does indeed work out to be this original polynomial, right? If we go ahead and multiply through with distributivity, the way we learned years ago, we get x times 3x is 3x squared, x times negative 4 is negative 4x, 1 times 3x is 3x, and 1 times negative 4 is negative 4, and then we can combine negative 4x plus 3x, of course, is negative 1x, and so we're back exactly where we started, exactly like we hoped for, and so we know these two factors are correct, and that this diagram indeed does represent this polynomial in factored form, okay? Now, another way, and even a way that might lead us into be able to think of the dimensions of a rectangle a bit faster, is to think, whenever we have a quadratic polynomial where the leading coefficient, the number in front of the x squared term, is not just 1, whenever it's anything else, right? We are now looking for 2 numbers that add, again, to make the middle term, the b, the -6, and simultaneously have a product, that is to say the multiply, to make -8 times 5. The constant term times the leading coefficient. So -8 times 5, that's -40. Okay? So now we're tasked with finding two numbers that add to a sum of -6 and multiply to a product of -40. You can take a moment and pause the video to think about it yourself, but you'll eventually come to find that those two numbers are -10 and +4, -10 and +4. So now what we do is, if you were to draw this, you could draw 5x squares, 5 big X squares, then you could draw 10 negative x's in one direction, and 4 positive x's in the other direction, and that would make the little pocket in the bottom right corner, like we did here for the 4 negatives, but you'd have 8 negative units in your bottom right corner, if you wanted to use the algebra taught. So you can try it on your own if you want, see if it works out. But what we're gonna do here is called decomposition. So we're gonna decompose this middle term, -6, into -10x plus 4x, right? Because what this line tells us is that -10x plus 4x is of course equal to 6x. So that's exactly what we're gonna do. We're gonna break up, we're gonna decompose this middle term into two terms. So -10x plus 4x minus 8. Okay, that's the big step. Once we've decomposed the middle term into the two numbers that we found, we're going to factor the first two terms. So we're going to factor 5x squared minus 10x, and then we're going to factor the last two terms. Okay? So what can we factor out of the first two terms? That's going to be 5x, and then inside the bracket we get another x, and then minus 2. Plus, what can we factor out of 4x minus 8? That's a 4, and inside the bracket again, x minus 2. That lets us know we're on the right track. We should be getting the exact same expression inside both brackets if we do know we're on the right track. And now to get our polynomial written in factored form, we have one factor of everything outside of the brackets. So outside of the brackets, we have 5x plus 4, which provides us with our first factor. And our second factor is everything inside the brackets. That's why they have to be identical, because this, x minus 2, is our second factor. And so here is our polynomial in fully factored form, 5x plus 4 times x minus 2. If you want to check that these two factors are indeed correct, you can multiply through the same way we did up here and make sure it's expanding out to the polynomial we started off with. Okay, you can try using the algebra and drawing it in a rectangle and ensuring that the two dimensions that you get for your rectangle are the same two factors that we found here. But obviously, this method is a lot faster, especially as the numbers get bigger and bigger. So, hope this helps. Any questions, comments, suggestions, please leave a comment. And thanks for watching.